In this presentation, I'm going to present the BpModelMasher framework, which is a framework for managing the problem of handling large number of process variants in an efficient and effective way. So this work has been done by Sharif Sakr, Ahmed Awad, and Emilian Pascalo. So the business processes are central concept for the operations of both public and private organizations. A business process is defined as a set of coordinated activities to achieve a specific business objective. Modern organizations build a large repositories of business process model to describe and document their daily business operation. As the size of these repositories increase, automated techniques for managing these repositories become crucial to improve the productivity and the quality of the designed business process models. So one of the reasons for having a larger repositories in business organization is one business process can exist in different variant model. So in practice, business processes don't exist only under a single version. It can have different versions which cover different issues in the whole market. For example, many variants of process model may exist with the same enterprise in order to deal with many different business situations, such as targeting different customer types, relying on particular IT systems, or complying with specific country regulation. A process variant as a concept is like a child class which is extended over or override the behavior of the parent process. In our demonstration, we rely on a scenario, real world scenario, which is running by the eBay organization. eBay has a number of process variants, which is up to 8,400 models. These models cover different domains like customer segments, sites, payment, department, and CRM systems and the channel. So with this large number of process models, many of these processes are coming from having different variances for the same process model. So currently they manage the variant process models by the traditional safe as style, that they have a specific process model, and then when they create another model for a specific situation, they just copy this model into another process model and make the required changes and save the child model as an independent process models without any linking to the parent model. So here is an example of a real-world process for customer relationship management. We have a process which track the relationship for processing an order with a customer or processing an event with a customer. So they take the call, they create a case manually in IPOP, they ask for authentication data, they authentify manually via a system called CSI, then either they end the track call or they add the customer case and ask issue. So here is in the top of this slide we represent the main process, the child process, which extended the main process by ending the process by either help or refer to line and end the track call, or ask for item ID and assign this item ID to a case. So this is two different process variants for the same situation, which are slightly different from each other, and they are running currently as an independent process models. So what is the limitation of the safe as approach? It's that, as we previously mentioned, we're losing the links or the relationship between the related model, and make it possible to have many redundant model and in any inconsistent situation. So if there are any updates has been happened in the parent model, they are not reflected at all in the child model, and the manual maintenance and the update of related models in large repository is nearly impossible. So our approach is to apply inheritance or use over the process model. So we apply process inheritance via using views, and the partial process model notion is designed to build these views, and with the notion of process models we can build our process models using two types of concepts. The first part is a concrete part, which is like traditional modeling concepts like event, gateway, connection, task, and so on, and the inherited part view, which is defined by BpMNQ query. So in short, BpMNQ is a visual query language which is used to design views or queries over repositories of business process model. It uses the same concepts and notation from BpMN, in addition to some querying special constructs which are used for querying, like the class construct, which is trying to find a subfragment in the process model which is links any two nodes. So here, for example, we have a query which have two tasks A and D, and we try to find in the original process model the sub process or the fragment which match with this query. So here we highlight this part which is having the two process, the two node tasks A and B, and the path between them in the original. So that is a subgraph which is matches to the query graph. So here we have a sample child process, and in this sample child process we have defined two parts of the process as views using query 1 and query 2, while the rest of the partial process model using a concrete element. So here, when we have the parent process and we have our partial process model linked to this parent process model, we match query 1 against its related part on the parent process, and we match query 2 against its related part on the parent process, and then the resulting child process will just be by linking these parts of the parent process into the child process model, and in consequence any updates will happen to the parent process model will be directly reflected to the child process model. So for example, if we change the label of one of the activities in the parent process model, it will be directly reflected in the child process model. If we add any activities or the tasks in the parent process model in this fragment of the view, it will be directly reflected into the child process model. Thank you very much for the presentation. You can watch an online demo for this for our framework in the coming screencast. Thank you.